So in our last physics class, we were discussing about motion along a straight line. In it, we have discussed about what is the position of a particle, about what is the displacement of a particle, and also we have discussed about what is the average velocity, average speed of a particle, and we have discussed the difference between the distance and displacement of a particle, the difference between speed and velocity of a particle, and then we have discussed a little bit about graphs and how to know what is the we had discussed about position time graph actually, and we had not gone to any complex graph, and we had discussed just simple graph. So this class we are going to discuss something a bit higher, that is instantaneous velocity and speed. So for finding the instantaneous velocity, uh, if you have a little bit knowledge of calculus, then it will be very beneficial for you for understanding this concept. Even if you don't have any knowledge of calculus, then also you can understand it. I will try my best to make you understand this concept, and it is very interesting. So let's proceed. So we already know what is average velocity. So when I write average velocity is equal to change in change in position by change in time. Okay, so this is the change in position or displacement. This we had already discussed in our last class. So now think that instantaneous velocity means that what is the velocity of the particle at that instant of time. Means if you see a car moving, so what will be the velocity at that instant of time? If I am seeing it now, then what is the velocity now? That is a very big question that we need to answer. So um, when I say instantaneous velocity, so how are we going to find the instantaneous velocity from the formula of average velocity? So how we will find that? We will find that by squeezing the time interval to zero, means close to zero. That means if I ask you, then what is the velocity? Another way of saying that what is the velocity now, if I ask this question, another question I can ask that what is the velocity of the particle after 0 seconds? Just think about it. What is the velocity of the particle after 0 seconds? So after 0 seconds means that it is in that moment only. If I say what are you doing? What will you be doing after 0 seconds from now? Then what you will say? You will say that what are you? That means what are you doing now? From 0 seconds from now means it is just this moment I'm talking about. So that is the difference. That is in this way we are going to tell the instantaneous velocity. We are going to tell what is the velocity after 0 seconds from now. So in physics and in mathematics, we don't directly, we never say zero directly. Means we cannot make the denominator zero directly. Means the delta t will be zero. That we don't do. We always do that. That delta t, that change in time that we are saying that after 0 seconds, that we tell that it tends to zero, means it is very close to zero. We don't tell it is exactly zero. In physics and in mathematics, we don't tell exactly zero, but we say that it is very close to zero. And when we say something is very close to zero, we put limits in that. So a mathematical way of whatever I said, to mathematically represent it, we write like this. Delta t means after how many seconds, which I told after 0 seconds from now. So that means very close to 0 seconds from now. Means 0.0000001 like that. Okay. So you can visualize that way. Hope you would understand it. So if I write limit delta t tends to 0. This is the way we write. We don't write the delta t equal to 0, but we write delta t limit delta t tends to 0. That means that the change in time is very close to 0. And what is the formula? Delta x by delta t. So this is the formula for instantaneous velocity. Okay. So here delta t means the change in time. The change in time is very close to 0 and almost 0, but very almost 0 means tends to 0. And so this is the way I am saying that what will be the velocity after 0 seconds. So it's very close to 0 seconds. We cannot do 0 directly. So very close to 0 seconds. What is the velocity? So if we get that, then that will be the velocity at that moment. Okay. So hope you could understand. Another way of writing this thing, this big thing, is like we write it delta x by delta t. Dx by dt. Delta x is replaced by dx by dt. So when I write delta, that means a big change. Means this is the symbol for a big change. Big change. That is big change in position by big change in time. And when I write dx, this is nothing but it's the younger brother. D is the younger brother of delta. That means D is small change. Okay. So limit delta t tends to 0, delta x by delta t is written as dx by dt. So by finding the value of dx by dt, we can find what is the velocity at that instant of time. So dx means small change in x and dt means small change in t time. Okay. So this is the whole concept of calculus. Okay. This is basically calculus. This is how we find, and when we will discuss calculus in our mathematics class, then you can very well understand what is it and how we'll discuss about the graph, how it is the slope of a line at that point. But let's not complicate things now. So just remember one basic formula of calculus, which we will be using in our next question. So this formula is d by dx of x to the power n is equal to n x to the power n minus 1. Okay, what is the meaning? That when we differentiate, always we differentiated something, a function, with respect to, means we write it like this, that we are differentiating d by dx, means we are differentiating the function. Okay, so when we differentiate a function, that is x to the power n, means t square, if I say, or x square, y x square, or t cube, x cube, like this. If this is the function, I am differentiating it. Then after differentiating, what we will obtain, that is the formula to remember, that n x to the power n minus 1, means if t square, if I differentiate t square, so what will be the value if after differentiating? It will be 2 into t to the power 2 minus 1 will be 2t. Okay, so in mathematics we will completely discuss that why it is like this and what is the meaning of d by dx. Actually, when I was in, studying just after 10th standard, when I entered the 11th standard, then I had a lot of difficulty with calculus because I was very new to calculus and I could not understand most of the why this is, what is the meaning of d by dx, why are we doing that. So uh, so that you will very well understand in mathematics, but in physics, just remember this formula. This is just a formula. We always differentiate a function with respect to, means x, like we always differentiate a function and with respect to the same function and in same variable, actually same variable, and after differentiating we get, this is the formula for, it is a simple formula, that x to the power n After differentiating, you will get n x to the power n minus 1. Okay, this is a simple formula, nothing complicated. Just remember this and we will discuss later about it. So this is the question. So in the questions I have given the formula of means what is the function of position of a particle as a function of time. I have given the position of the particle as a function of time. So I have given it. So you have to find the velocity in each case. So see, this is the formula of instantaneous velocity. Okay. So I will give you the function, displacement of a particle as a function of time, the position of a particle as a function of time, and then you have to tell me what is the instantaneous velocity. Okay. So if the first question is, you have to tell me velocity and which situation, you have to tell me which situation the velocity is constant and in which situation the velocity is in negative direction. Okay. It is simple. So the first question is x equal to 3t minus 2. It is just a function. That is the position of a particle with respect to time. Okay, the function. So at suppose this is that means that at t equal to 2 seconds. Just imagine the position of a particle will be 2 into 2, 3 into 2 minus 2, that is 4. Okay, so this is uh, the meaning is this, that at any time t, that t can be 2 seconds, 3 seconds, 4 seconds, the position of a particle is represented by 3t minus 2. Okay, so at t equal to 2, it will be at x equal to 4. So you can see that the position will be somewhere like in x equal to 4. Here, if this is the origin, and we define the right side as the positive direction, then here it will be, the particle will be here. So at t equal to 2 seconds, the particle will be here, right side of the origin and 4 meters from the origin. This is the meaning of the whole this whole equation. The position as a function of time. Okay. So this is how we write in physics the position as a function of time. And you already know the formula for differentiation. So the derivative of a constant is 0. Okay. So if I say what is the derivative of 3, if I say what is the derivative of 3, then it will be 0. Also 4, 5, any constant, it will be 0. The derivative, when we calculate the derivative. Okay. So hope this is the just if you are learning this for the first time, then it will be quite useful for you, and you can relate it uh, to whatever you learned previously. And this is very easy actually. Uh, if you don't know calculus, then also you can understand it. It is very easy. So this is the question. So it is the position as a function of time. So you have to tell me the velocity and the where. And another question is x equal to minus 4t square minus 2. Okay. So yet another question is x equal to minus 2. Okay. So you may pause the video and find the instantaneous velocity in each of the cases, and you have to tell me where the velocity is constant, which case the velocity is constant, and in which case the velocity is in the negative direction. So you have to tell me. This is just a basic application of differentiation. Okay, so the answer is, what is the answer to the first question? So we will find the derivative of this dx by dt. that is the instantaneous velocity. As we know that dx by dt is the instantaneous velocity. So what it will be? So it will be 3. This is the derivative. This is the constant. So it will be 3 into derivative of t. So what is the derivative of t? So it means t to the power 1. So it will be 1 into t to the power 1 minus 1. So t to the power 0. As you know, t to the power 0 or any function x to the power 0, anything to the power 0 is 1. So the derivative of t will be equal to 1, and we have a function 3, so we will just simply in derivative also we will simply multiply it to 3. So it will be 3, and the derivative of minus 2 is 0. So the answer will be 3. Okay, 3 meter per second. Okay, so by differentiating this function we got 3. Okay, so this is the basic. You can look at the formulas of what is the formula derivative, and you can practice 2-3 questions of finding the derivative of functions. Okay, so it is very easy, just the application of formula. So in this, you can see that I had asked you the question that where the velocity is constant. So in this case, the velocity is constant as just 3 meters per second. So in the second question, we will find the derivative of this function. So if you could not solve the first question, then please pause the video and again try to solve these 2 questions which I have given you, and then you will proceed to the answer. Okay. So first we have to find. So for instantaneous velocity, we have to find dx by dt. We have to find dx by dt. So it will be minus 4 into, so derivative of t square, it is 2 into t to the power 2 minus 1, that is 1. Minus derivative of 2 is 0. So it is minus 8t. Okay. So for the second question, the instantaneous velocity is minus 8t. What does that mean? That at any time, say 2 seconds, 3 seconds, the velocity of the particle will be minus 8t. Means at t equal to 2 seconds, the velocity will be minus 16. At t equal to 3 seconds, the velocity will be minus 23, minus 24. Okay, so like this, we will proceed. Okay, this is very simple. So you can see that from the simple mathematics we could get what is the velocity of the particle at any instant of time. So it is a very useful thing. Okay. So I had asked you a question that at which case the velocity will be negative. So this is the case. This is the case where the velocity is negative. As you can see, it is minus 80 because t can never be negative. Okay, we cannot say minus 3 seconds. We always say 0 seconds or 2 seconds or 3 seconds or 4 seconds. So t is always positive, and we had already multiplied a negative with a positive. That means minus 80. So this negative sign indicates that this velocity is negative, in the negative direction. So in this case the velocity is negative. In the third question, it is x equal to minus 2. As you can see that x equal to minus 2, it means that the particle is not moving. Just forget about finding the derivative and all. Just think what is it representative in physics. So x equal to minus 2 means the particle is situated at some point that is in the negative direction, that the left side with the negative direction is the origin, and here it is minus 2, this is the position, and its position is not changing at all. You can see that always at any time, if you put, that means minus 2 means into t to the power 0. So if I take t equal to 3, then 3 to the power 0, this is also means t is not at any time t, at 4 seconds, at 5 seconds, at 7 seconds. It is always located at x equal to minus 2. That means the particle is at rest. The particle is not moving at all. because with time, always its position is x equal to minus 2. If I tell that something at any point of time, if I see a particle at one position only, then we say that it is at rest. So here this particle is at rest, and where it is resting? It is resting at x equal to minus 2. Okay. So after in mathematically also we can prove this one by finding dx by dt. As you can know, the dx by dt of a constant, that is any number, is 0. So by mathematics also we can see that dx by dt equal to 0. That means the velocity is 0. Okay, velocity is 0. That means the particle is at rest. Okay, so mathematically also by finding dx by dt, we found that dx by dt equal to 0. So the instantaneous velocity is 0. That means the particle is at rest. Also, by seeing the equation also we can say that, because the position is not changing with respect to time. The position is not changing with time. That means the particle is at rest. It is very simple, you can think like. Next, we will discuss another concept, that is acceleration. Okay. So, what is the meaning of acceleration? So, whenever the velocity of a particle changes, in velocity, I had told you that when the position changes with respect to time, then we call it velocity. That is average velocity. What is change in position by change in time? That is displacement by time. Change in position means displacement by time. That is, we told that is average velocity. And similarly, average acceleration means the change in velocity by change in time. Means what is how at what rate the velocity is changing. Okay, so rate with respect to time. Okay, so at what rate the velocity is changing, that will tell us what is the acceleration. That word we use in physics is that acceleration. So what is average? Average velocity. Sorry, average is average acceleration. Average acceleration equal to change in velocity by changing time. Suppose velocity at some point of time t2 is v2, and at t1 it is v1, so it will be v2 minus v1 by t2 minus v1. Okay. So this is the average average acceleration of the particle. This we can relate the formula of average velocity. That is delta x by delta t. Similarly, the average acceleration is delta v by delta t. What is change in velocity by change in time. Okay. Similarly, as we had discussed about instantaneous velocity, we can also discuss about instantaneous acceleration. Okay. Instantaneous acceleration means that like we squeeze the time interval to 0, and I said that what is the acceleration after 0 seconds. That means what is the acceleration now, and we don't say exactly 0, we say tends to 0. So similarly what we did before some time, we will do it again. It is limit delta t. This is the way of writing delta t tends to 0, delta v by delta t, that means equal to dx by dt. Okay. dv by dt. dv by dt. Okay. So this similar way we found that this is dv by dt is equal to acceleration. The instantaneous acceleration A is equal to dv by dt. Okay. So acceleration is a vector quantity. I had already told you what is a vector quantity in the last class. I had told you. So that means that the direction of acceleration matters. Okay. You cannot say that acceleration is just 5. You have to specify the direction. It is -5 or +5. Minus and plus represents the direction, so you have to tell me. So in that way you can tell that what is the meaning of acceleration. So let us discuss one misconception of many students. I have heard many students saying that negative acceleration means retardation. Okay, so that is the misconception. Negative acceleration doesn't mean retardation. So I will explain you how it is wrong. So what is the meaning of negative acceleration and what is the meaning of retardation? Retardation means the speed is decreasing. Okay, retardation. So our misconception is negative acceleration, retardation. That I am explaining how it is wrong. So retardation means speed is decreasing. Speed means it can be in any direction. So if what what I mean by retardation is if now the speed is 10, after some time the speed will be 8 or something less than 10 and it will go on decreasing. Retardation means that the speed is decreasing. Negative acceleration means that the acceleration is in the negative direction. Whichever direction we have choose as the negative direction, that in that direction the acceleration is in that direction. Okay, so if the left side is the negative direction and right side is the positive direction, that means that the acceleration is in this direction. You can imagine acceleration as a force that is changing the velocity. Okay, something that is changing the velocity. It may be increasing the velocity or it may be decreasing the velocity. So negative acceleration means the acceleration is in the direction in which we have chosen the negative, in the direction in which we have chosen the negative, uh, chosen as negative direction. So if the left is the negative direction, then acceleration is towards the left. Okay. Retardation means speed is decreasing. So most often we think that the velocity is in the positive direction. We always we think that if the velocity is in the positive direction, that is the right side, and if the acceleration is in the negative direction, that is the left side, then only the speed will decrease. But what if the acceleration is negative, that is negative acceleration, but the speed, that the velocity is also in the negative direction? What will, in this case, you can see that the velocity, this is the velocity, say 2 meter per second. This is in the leftward direction, that is the negative direction, and the acceleration, that is 2 meter per second square, it is also in left, that is the negative direction. If both have the same sign, then negative, even after having negative acceleration, the speed of the particle will increase. You can just see that in this direction the acceleration is there. That means that I always imagine acceleration as a force. See that the particle is moving like this and a force is applying on this side only, the same side in which it is moving. So obviously that force will increase the velocity of the particle. It is not a drag. If it is moving in this side and I will drag this particle, the acceleration is in opposite side. Then the velocity will decrease. That if a person is running and I am dragging that person from behind, then his speed will decrease. But if a person is running and I am pushing him, then his speed will increase. Similarly, the two velocities are in same direction. Means the acceleration is in negative direction and the speed is also in the velocity. The direction of velocity is also in the left side, that is the negative direction. So that acceleration will always increase the speed. Okay, we are pushing that body in the same direction. So if both are in the negative direction, then in that case the speed will increase. So we had assumed that negative acceleration means retardation. So that is wrong, because we have not yet specified what is the direction of velocity. We need to first specify what is the direction of velocity. Then only we can say that it is retardation or it is acceleration. Means if the speed is increasing or the speed is decreasing. So just don't remember like this that negative acceleration retardation. Whenever I say retardation, then just ask what is the direction of velocity and what is the direction of acceleration. If both of them are in the same, if acceleration and that is acceleration means just imagine a force and the velocity are in the same direction, means in which direction the person is moving, I am pushing that person in the same direction. That is the meaning of acceleration and velocity is in the same direction. And if acceleration and velocity are in the same direction, then the speed of the particle will increase. That means the person will run faster. If ball is just rolling like this and I'm pushing it in the same direction, then obviously the speed of the ball will increase. Similarly, if the velocity and acceleration are in the same direction, then the speed will increase. And if the velocity and acceleration are in opposite direction, then the speed will decrease. If this is the direction of velocity and in the opposite I am dragging the particle and the particle is trying to move in this direction, then the speed will obviously decrease and slowly it may come to rest, and again it may, that is the whole journey of the particle. So I hope I have cleared this misconception of many students that negative acceleration is retardation. Don't think like that. Think that negative acceleration means the acceleration is in negative direction. Retardation means the speed is decreasing. The speed will decrease only if acceleration is in negative direction and velocity is in the positive direction. But if both are negative, then the speed will obviously increase. So one thing you have to remember is that if the sign of velocity and acceleration are opposite, okay, in one dimensional motion, if the sign of velocity and acceleration are opposite, then the speed of the body is decreasing. Okay, that means the value of the magnitude of velocity. Speed means the magnitude of velocity at that is instant. The speed at one instant is the magnitude of velocity at that instant. So if the speed if the sign of velocity and acceleration are opposite, then the speed of the body is decreasing. And if the sign of the velocity and acceleration is same, that is both positive or both negative, then the speed is increasing. Okay, so you have to remember this thing, that the sign of velocity and acceleration both are same, then particle is the speed is increasing. If both are opposite, means one is positive, one is negative, then the um, speed is decreasing. This is the thing. This is how you have to remember, not this thing which is written. So to get a greater clarity, we will solve one question. So the question is initial velocity of a car is minus 25 meter per second. Okay. Now brakes are applied. So the velocity of the car will decrease, the speed will decrease as we are applying brakes. And after 5 seconds, the car stops. Okay. I'm not writing everything in words. After 5 seconds, the car stops. Then what is the average acceleration? Okay. So whatever I had discussed earlier and whatever concept you have learned, just pause the video and think what will be the answer to this question, and then only see the solution. Don't hurry, the answer is, as you know that the final velocity, it stops means the final velocity is 0. So the final velocity is 0. Final velocity is 0. What is the initial velocity? Initial velocity is minus 25 meter per second. What is the meaning of minus 25? If this is the origin, then the car is moving in this direction. That is the left. Okay. If we choose this is the negative direction, left is negative and right is positive. So the car is moving in the negative direction. That is the left side. The car is moving towards the left. So finally it stops. What is the time taken? Time equal to 5 seconds. As we already know that acceleration means change in velocity by change in time. So what is the meaning of change in velocity? That is final velocity minus initial velocity by time. So what is the final velocity? It is 0. Okay. Minus initial velocity. Initial velocity is minus 25. You have to put always this velocity with the sign. Don't put 25 instead of minus 25. Okay. So always put the velocity along with the sign. So it is 0 minus minus 25 by 5. Okay. This is our, recall our definition of average velocity, average acceleration. So from there I have written this equation. So it will be 25 by 5 equal to 5 meter per second square. So it is plus 5 meter per second square. That means the acceleration is in the positive direction. Okay. So this is the direction of acceleration. So the velocity is in the negative direction and acceleration is in the positive direction. So here you can see that acceleration is positive, but still the speed of the particle is decreasing. Okay, acceleration is positive, but the speed is decreasing. So this is our misconception we had, that if acceleration will be positive, the speed will increase. No, here the acceleration is positive, but speed is decreasing because the velocity is in the negative direction, and the velocity and acceleration both have opposite directions. So the speed is decreasing. You can just think that someone is running in one direction and I'm dragging it in another direction. So obviously the speed will decrease. So here you can see that even though the acceleration is positive, still then the speed is decreasing. Okay, as it is stopping after some time, it is the speed is 0. So so this was it for this class, and in next class we will discuss about the equations of motion. That is the special case of acceleration, when acceleration is constant. We will discuss what will happen. That is a special case, so it will be very interesting. So till then, bye.